Okay, I'm going to measure myself in terms of how I'm doing on time. Let's see how that goes. Just kick me off stage when I run over 15 minutes. This is only fair. Oh God. Okay. All right. Here we go. Cool. So tonight I could introduce myself. I'm the MC. It's like, and the next speaker is going to be. No, I was just kidding. So I would like to talk today about web authentication, or Web Authn in short. This is really, really cool, and I want to explain to you why I think this is cool. And it's pretty early on still, but it also is pretty well like the right time to actually get going with this. And I think a very open secret in IT security is that passwords absolutely suck. However, I'm pretty sure every single one in this room, including me, is using plenty of passwords, or at least one. And the thing with passwords is that if we are trying to intuitively make it hard, we are making it really, really hard for us to deal with the passwords, but we are not really making it hard for a computer. If you look at the first password, it's like there's so many opportunities to not actually remember. It's like, oh yeah, there was this, I had a word and then some special character, and some of the letters were actually switched with numbers. But if you look at how hard this is actually to guess, you would figure out that it only takes 3 days if you have 1,000 guesses per day. And that's, a second. 1,000 guesses a second sounds a lot, but for a human it is. If you're like, Bob, no? Okay, Alice, no. Okay, password? No. Okay, root? No. Okay. Then yes, 1,000 guesses per second is a lot for a human, but for a computer, this is actually really, really easy to accomplish. So we might be very much below 3 days of time taken to actually crack a password. If we make a sentence like correct horse battery staple, which you should not use because this is now in the internet, so every tool is now probably checking for this specific sentence as a password. But basically, if we have this, we have a lot more bits of entropy, so it's a lot harder to actually guess. It takes a lot longer. In this case, again, assuming 1,000 guesses per second, it would take 550 years to guess this. But no one does their passwords like that, or very few people are doing it like that. You are doing it. I have actually like multiple sentences as my password, and then you always have these fantastic services like, no, your password has to be between 6 and 12 characters, and I'm like, thanks. That's for security reasons, and I'm like, yeah, that makes sense. And also, the other thing is, as I said, many of us have many passwords, or at least one, because it turns out that many people, out of fatigue of having to remember different passwords, are using the same password. And I have to admit, I do have a password that I use for bullshit accounts where I'm like, yeah, if this is getting hacked, who cares? Which happens to be my Yahoo email password from back in the days, because that is hacked anyway. So I'm actually also falling into the group of people who do reshare passwords, at least for this specific group of accounts. But yeah, don't do that. But everyone does it unless you have a good password manager and you always are on a device signing up for the thing where the password manager intercepts and suggests a password. Chrome does that now as well. But still, the point is, like, a lot of people, if you get one password, you actually have access to multiple accounts. And that can get really, really tricky because someone might use the same password for their email account as well as for their Yahoo email account, and then it's their banking password as well. So if I go through trying every password that I found in the Yahoo hack, I would actually get access to their account. And that works quite well, unfortunately. So passwords are actually, most of the times, we have a hard time remembering. So they're hard to remember. And they're annoying to manage because at least I am dealing with so many different devices on so many different occasions. I sometimes have to enter my Apple ID password on my fucking television. Sorry, I shouldn't have sworn, but like, oh God, why? So it's annoying, and I obviously don't have a password manager on my Apple TV. So, great. They can be leaked. So even if I am doing well and have different passwords, there might be a leakage. The database might have been like, taken into the internet by a disgruntled ex-employee, or maybe they had like a security issue and the database was dumped by someone. So then that password, in the worst case, might actually be out there in clear text. In the best case, it is a salted hash, so they can't really do that much with it. But still, there is a risk that I am not even like the perpetrator of accidentally sharing my password with the internet. It can also just be guessed. In the end, everything that we know, there's a fantastic novel, or actually a theater play, drama, by Friedrich Dürrenmatt, the physicist. It's about the fact that something that has been thought of can be thought of again by someone else. You can't really control that. And so even if I come up with a fantastic password, someone else might figure it out nonetheless. just by sheer luck or by just trying long enough. So it's not exactly great. So what can we do instead? And the agreed upon way of dealing with this is multi-factor authentication, or in the simpler case, two-factor authentication. Now, what is two-factor authentication? Well, it's something you know. So like an email and a password, probably, something that I have in my head, and I could share this. I could share the thing I know, because as I said, thoughts can be thought by someone else as well. But also it's something I have. And again, it's something like a key. I could give you the key, but if I don't tell you the code on the code lock next to the actual lock with the key, you can put the key in and unlock that lock, but you can't really, you don't know the code. So now we have something that I possess, that I have physical access to, and something that I know, like a password. So now even if one of the two gets compromised, you can't really do much because you have to have both of them. But that also means that we have to make sure that the two factors are actually two factors. And that's not always the case. So for instance, SMS with a code, technically that is like a thing I have. Like I have access to my phone. So if an SMS gets sent or a text message gets sent to my phone, then it can hopefully, unless you are dealing with like a state attacker or state level attacker, nation state attacker, then it can reasonably be expected that only I can read that SMS. Email with a code, yeah, sure. If I have access to my email account and only I have access to my email account because I might be using a different kind of two-factor for my email authentication, then that's relatively safe. Or I use an app like the Authenticator app or Auth to actually generate like one-time password codes. Whenever I log in, I have to use the app to actually get the code and then log in with that. Fingerprint sensors, that's a really nice one because hopefully my fingerprint is something that I own and I have with me at all times. And it is easy to copy, but still it is quite a bit of effort. You can't really, some scammer in another country cannot easily scam this. They would have to physically get access to a glass of water that I touched or something like that. So it at least isn't as easy to get possession of unless you're dealing with physically present attackers. Security keys, another thing. I literally have a security key on my keychain, and I can use that. And as long as you don't get access to it, and as long as I make sure that I deactivate it if I would lose it, you again cannot get anywhere close. I can give you my security key because you don't know my password at least. So again, two factors make sure that it's very much harder to get into things. But as I said, it has to be two factors. Is all of these really, strictly speaking, two different things? Is it really separate from each other? It depends. It's not really always the same. So for one thing, if I am trying to log in on my phone and I have a malware on my phone, the malware can read when I enter my password, and the malware can probably also read when an SMS code arrives. So it could intercept the SMS. I'm not sure if you've ever used an app like Uber where you do have like this verification SMS coming in and they intercept that, so you don't really see it until after the app has done something with it. So then basically I could intercept that. The same goes for email. Again, I'm on my phone, the phone has malware on it, or like some attacker is phishing me in some way, and then I enter my email address, my password, and the email code that I got. They can intercept that and use that to log into the real thing, and again I broke two factors. However, the apps might be safer. But still, if I am having the scenario that I have a malware on my phone, then I'm still not safe. If I'm trying to log in on my phone, and I do that every now and then the app intercepts, or the malware intercepts that, plus the code from the app, then I'm back to square one. I do not really have two factors. However, if I have a security key and a fingerprint sensor, that is already harder. Because these keys happen to not really disclose the private keys that you would need to generate a new secret. They only disclose their public keys. So whenever a request comes in, you only get a public key, and then it's being signed with whatever you have as a secret on your server, and then you can't really, the public key is not enough to fish that off. There are successful attacks shown by the FBI, I believe, against email, SMS, and apps. There hasn't been one against security keys. And the same goes for fingerprint sensors, even though they haven't explicitly mentioned it. But I think they're pretty much on the same level because they use cryptographic keys to actually make sure that you can't just use that and paste it into something else. Security keys also usually have a little button. I think I had it here. You see like the little golden plate there with the key on it. That's a button you have to press. not really a button you have to put your finger on or anything. Like you could probably use a sausage or something, I don't know, I've never tried. But basically you have to put something on there. You don't really have to press a button or something, but you have to be physically present to actually generate the secret you need to log in. So even if it's plugged in into your computer or phone, it can't be read from unless you have a user gesture. So the user has to be present. And it has a bit of history already. So in 2012, Yubico came out with the YubiKey. That's like one of the first security keys that were commercially available, basically. Google and NXP came together with Yubico and basically founded this universal two-factor, which is a set of standards that should allow every application and everyone on every device and every platform to actually use two-factor authentication to secure whatever application they want to secure. Then there is like a larger industry alliance that actually came together as the FIDO Alliance. I know I have 5 minutes, that's gonna be fun. So they are basically like standardizing more things, and in 2014 we saw the first open source implementations, and since 2016 FIDO 2.0, which is a new set of standards, actually came out, and as part of that there is also a new browser API. The browser API part of all this magic is called the Web Authentication API. Let's have a look. So what is Web Authentication API? Well, fundamentally, every browser that supports it right now, that is Firefox and Chrome, have possibilities to actually, and Edge actually, because they're using Chromium. So they kind of support it as well now, I guess. Sorry, I haven't updated this, and like 3 months ago or 4 months ago, it wasn't necessarily on Edge, I think. Anyway, now we have this wonderful API. Looks more or less like this. So I'm trying to log in with a user that doesn't exist. I can register this user. I have skipped the password. You should have a password, right? But passwords we know how to do. But have you seen that? Like, oh, hold on. Okay, I registered with my fingerprint. And now if I'm trying to log in again, imagine that I would put in a password. I can either use my security password on Mac OS, or in this case, I used my fingerprint. If I would go somewhere else, like I'm now an attacker, and I'm trying to do the same thing, then I can't. Because this browser is not registered, it does not have the credentials, and the security key cannot actually generate a new key pair for this that easily. So I would have to log in on a device and basically register this device to be safe and secure for two-factor authentication. Now, that's great. How does that roughly look in code? I am focusing on the front-end code now. The back-end code we can actually have a look at as well if you want later on, but not in this talk because I only have 3 more minutes. We basically have to create, on the server side, we have to create a challenge. I'm doing this here by just getting myself 64 random bytes. We have to save that on the server side, then we have to send that to the client. And then in the client, we basically run the Web Authentication API that uses this challenge and a few other data bits and pieces to then create a cryptographically signed blob of data. This blob can only actually be coming from the original device. We can verify that by checking if the challenge is the same and if the signature matches what we expect. And then once we have that, we can basically use this to extract the public key from this bunch of data. And then we have a public key to a public-private key pair. The public key can be used to make sure that the other side is who they say they are, but it cannot be used to pretend to be that side. A bunch of crypto behind that I'm going to skip happily. If you have questions about it, definitely come to me and ask me. But then we basically save the public key in our database, and the next time we want to make sure that someone is who they say they are, what we do is we basically say, hi, I know that you have registered beforehand, and I have your public key, which is great. And I know that for you, the ID, one of the many bits and pieces that we got is the ID of the credentials that we created on the browser. We say, like, do you want to log in? That's great. Here's a new challenge, a bunch of random data, basically. And here is your credential ID. Please sign this challenge. And then they sign the challenge on their side. That happens in the browser again. And they send back something that is called an attestation. The attestation is a bunch of data that says, like, hi, so this was the challenge, this is the signature, and I am who I am. And then we can use the stored public key that we have in our database to see if this challenge, this attestation, the challenge and the signature actually come from the private key that is stored in your browser. If it isn't, if an attacker tries to impose and basically be like, yeah, I'm that person, they cannot cryptographically generate the signature that actually matches what we have in our database. Because they don't, even if I would give them the database with everything that I have on my server, they cannot figure out a way to actually generate a signature that matches the private key that is on the person's computer, the person who's trying to log in. So that's roughly how that works. I know that's a little abstract, and again, this is usually a 45-minute talk, so I have done a little demo as well. So I implemented this as a, okay, thank you very much, that was not full screen. Wow, okay. Great, now we have full screen. I'll zoom in a little bit. So this is a standard WordPress. There's nothing fancy about this WordPress. I have an, okay, thank you. Interesting. Okay, WordPress. I have a plugin here that I haven't activated yet. It's called Web Authentication or Web Authn. I activate the plugin real quick, and then I go into users, and now there is something that hasn't been here before, which is a setup two-factor authentication button here, right? Okay, let's click on that button. What does happen? What's happening now? Nothing, because I think I broke the plugin. Oh, that's fantastic. Great, that's what happens when you don't check your demos before you actually do the demos. That's lovely. Okay, normally that would be a user flow. Let's do it here. This is an even simpler demo. This is like a really, really stupid demo. Hi, I'm Martin, and I say test as my password, and I want to log in. I cannot log in. It says login failed because this user doesn't actually exist. Because I couldn't be asked to actually implement a database, it just keeps like the username and password and stuff in the memory. But I can register. Now it gives me options. So this is basically, the JavaScript has said, please create credentials for two-factor authentication. It's one API call. And now I get this wonderful option here. I can either use a USB security key or I can use a built-in sensor because this MacBook happens to have a fingerprint sensor. Now, if I use my finger and put it in here, then it goes like, do you want this site to have access to your newly created key pair? Yes, I would like that. And now the website says, yes, we're successful, that's cool, that's great. And now I can type in something else like ISDF, this is the wrong password. And obviously the thing goes like, okay, you can try that. And login is successful because I haven't actually implemented the password check. But it worked. It worked with my fingerprint. But now let's do something similar. So now I'm an attacker. I'm in a different browser. Let's see. Let's go into this incognito window. I'm in a different browser now. I go to the same site. And as I said, the password field isn't actually being used. So I'm just going to go like Martin. And I want to log in. It does the same thing, but in this case, okay, that's because I'm in the incognito browser. It doesn't even have access to the fingerprint sensor. So let's try a different Chrome profile. I think I have a second actual user profile. Which user am I logged in as? Okay, that's definitely my corporate user. That's great. Well done. I have a very serious profile picture for work, obviously, because we are very serious people there. So let's actually get a new browser window. Oh God. Don't shame me on the amount of tabs that I have open, okay? I know I shouldn't be doing this, but here I am. So now this is an attacker browser, and it tries to do the same thing. And even if it has my fingerprint, let's try this. It didn't even ask me to it didn't have an opportunity to even put my finger on. Why? Because this browser doesn't have the right credentials ID. I don't have time anymore to show you more, but basically I could go on and copy the thing that was created in the other browser, copy it in here and try to attack it. It wouldn't work because the private key cannot be extracted. So to sum it all up and give you the next speaker, Web Authentication API is a fantastic opportunity for you to build more secure web apps, and it's actually relatively easy to work with. There's a bunch of integrations and APIs already. I'm working on bringing it to WordPress core. Definitely check out if you can and want to use Web Authentication API, because I think passwords suck, and Web Authentication API is a great first step to actually get into a world where passwords are less crucial and less problematic. Thank you.